Hello everyone, welcome to watch this video. My name is JIA Li, Assistant Professor from Cal Poly Pomona. Today I'm gonna introduce our experience about how to incorporate sustainability education into the senior process design courses. So first, I would like to talk about the challenges to do this kind of things. And then I will introduce our efforts to introduce new sustainable process technologies into design and compare the new one with the traditional one with enhanced assessment method. More specific, our new technology is wind-based water electrolysis for ammonia synthesis, and our traditional one is Seth-Brown technology. And also we invite industry people, industry senior engineer and experts to review the student's design at the end. Finally, I'm gonna summarize what students would learn from these courses. So this sustainability education is required by AIChE, and we need to incorporate like economic, environmental, social, and different kind of factors into our system, component, or process design. So from this requirement, the senior process design courses is on a unique position to incorporate sustainability education. Of course, there are several challenges we need to address. First, we need to design a new process. And this new process have some sustainable features like biomass, renewable energy, novel business model, and so on. And also, from my point of view, we need to compare this new one to the traditional one in a quantitative way so that the student could gain the insights of those technologies. And because many of those sustainable technologies, they are under development, so we need to fill the gap between the university study and the real-world environment, and also fill the gap between existing status and future development. Okay, next, I'm gonna introduce our experience, our efforts we have made starting from 2017 to incorporate sustainability education into our capstone design project. This project is designed for around 30 students for one semester, about 15 weeks. And we divided the 30 students into two groups. And one group is to design the traditional Seth-Brown technology. Another group is to design the new distributed wind-based water electrolysis for ammonia synthesis. So both groups, they design these two processes in parallel. And to compare them, apple to apple, we also introduce an enhanced assessment method. This method could integrate sustainable factors beyond the traditional technical economic analysis. And at the end, we invite industry experts to review the student design. So for this traditional process, we use Seth-Brown, which use natural gas as a raw material and go through this steam reforming, water gas shift, CO2 removal, ammonia synthesis, separation, and so on. So this actually is a project that we have already used for more than 15 years in our university. And we do the mass balance, do the process simulation, heat exchanger network design, equipment sizing, capital and operating cost estimation, and financial analysis. So this is a well-developed process design project. And for this, starting from 2017, we introduced this new one. This new one, we got electricity from wind turbine. And this electricity used for water electrolysis and produce hydrogen. And nitrogen is come from air separation, and so we combine, we synthesize ammonia from hydrogen and nitrogen. So this is, we call it distributed wind-based water electrolysis for ammonia synthesis. We also do the same procedure like mass balance, process simulation, equipment sizing, capital and operating cost estimation, and financial analysis. But the new feature is that here we introduce an enhanced assessment method. This one is Excel based. We export the mass and energy balance information from process design. And then we introduce several models in this Excel platform. For example, the CO2 emission credit, renewable energy discount, and module manufacturing discount, and so on. So those models combined with those traditional tycho economic analysis, then we could do a financial analysis and get this multi-objective evaluation, or we study some key parameter, sensitivity study, and also make an optimal design. So the procedure is like this. We have PFD, and we go through the process simulation, and we go to the Excel-based assessment method. And those Excel sheet have already included all these sustainability factors. And then we give this, for example, we could compare the break-even cost for the ammonia. So compare the traditional one and the new technology, apple to apple. So let's take a look for this final result. If we only took this traditional tycho economic assessment, we can see this traditional hyperpodge. The break-even price for ammonia is like about $500 per ton. And this distributed, the new technology, the price is almost 3 times more. So if we only talk about traditional assessment, it seems there's no way for this new technology to compete with the traditional one. However, if more evaluation area are integrated, and then we could say, for example, if we integrated the CO2 credit into our consideration, and this one could reduce the price more than $100. And if we have a discount from this wind-based renewable electricity, we could also reduce the ammonia price dramatically. And for the new technology, we have actually we have dozens or even hundreds of this small scale plant, and those things are identical. We could manufacture it as a modular process, so it could reduce the cost of manufacturing, shipping, transportation, and installation. And in that way, we also expect we could have a big discount from that part. And also we could use low pressure synthesis reactor, and also if we could sell oxygen, we could also get some credit from that. So by accounting all those factors, sustainable factors, let's see. And from this new assessment, the new price for this new technology is about $563, which is comparable to this traditional technology. So this wind-based technology is a competitive and promising technologies. And also, this is a very good tradition that at the end, we will introduce industry people from like Wally Parson, Aviva, Flora, Chevron, and those people in to our campus and listen to the students' presentation for their design. And they give a very good comments and also valuable suggestions to our design during these years, and really appreciate for their support. So what students could learn from this sustainability education? First, they could obtain process design experiences on both traditional and more sustainable technologies. And also, they could gain the insights of these sustainable technologies by the enhanced evaluation method. They could compare the new one and the traditional one in a quantitative way. And also inviting industry people to review their design could increase students' visibility to the industry and help their career paths in the future. Every year, we have several students got job offer from those big companies. So in overall, this is a very good experience and good efforts we have been made to make students learn more about sustainability and also make them more ready for this rapid changing chemical engineering industry. Thank you, and welcome for questions.